Here I have the eigenvalue -2 repeated 3 times, so I need to find 3 eigenvectors that correspond to -2. What I'm going to go ahead and do is plug -2 into the lambda subtracted matrix. I'm going to put that minus lambda here, here, and here. And when I plug in -2 to this lambda subtracted matrix, I get -2, -2, 5, -1, -1, 4, and -1, -1, 3. I'm going to augment this with a column of zeros and row reduce. What I'm going to do is I'm going to swap row 2 into row 1, and I'm going to multiply that row 2 by -1 before I do that. So this is going to give me 1, 1, -4. The middle row now becomes -2, -2, 5, and the bottom row stays -1, -1, 3. Okay, now I'm going to add twice row 1 to row 2, and I'm going to take 1 times row 1 and add that to row 3. This is going to leave the first row as 1, 1, -4, but this middle row now becomes 0, 0, -3, and the bottom row becomes 0, 0, -1. I'm going to augment with zeros again. I'm also going to divide this middle row both through by -3. So I'm going to say row 2 divided by -3. This gives me the matrix 1, 1, -4, 0, 0, 1, augmenting with a column of zeros. Now that I have a 1 here, I can use this 0, 0, 1 to make this 0, 0, -1 a row of zeros. And last thing I'm going to do is I'm going to add 4 times this second row into this first row to make this -4 become a 0. Okay, I've got my row reduced echelon form. I want to label my pivots and my free variables. This is a pivot. This is also a pivot. This cannot be a pivot because there's already a pivot in this row, and there's no non-zero terms underneath it, so this must be a free variable. Let's write the equations associated with these pivot values and this free variable. So I have x1 plus x2 equals 0, and this last row reads x3 equals 0. Now x3 is 0 by default, so we're just going to go ahead and put that in our eigenvector. However, I have x1 plus x2 equals 0, and I can choose whatever I want for my free variable. I tend to let my free variable, which is x2, equal 1, and if I solve for x1 from there, I get -1. This is my first eigenvector, but of course, I need 3 more because, or rather 2 more, because I have a total of 3 repetitions of lambda equals -2. So how do I go and find that second eigenvector? I got to take this vector here, -1, 1, 0, and augment, instead of a column of zeros, augment it with the vector I just found. So I'm going to replace these zeros with -1, 1, 0. And once I do that, I row reduce all over again and find a new eigenvector. So watch, here I go. Okay, now that I've row reduced, I've got new equations. This is x1 plus x2 equals 3. This middle row says that x3 equals 1. Let's go ahead and set up my eigenvector. x3 is by default the value of 1. And then I can choose whatever I want for x1 and x2 so long as this equals 3. I'm just going to let x1 be 3, and I'm going to let x2 be 0. Okay, I could have obviously done 0, 3, 1, but 3, 0, 1 is pretty easy for me. So that's my next eigenvector. Well, now how do I get my third eigenvector? Well, once again, I'm going to take this new eigenvector of 3, 0, 1, augment my matrix instead of with the old eigenvector of -1, 1, 0, or with a column of zeros. I'm going to augment with the newfound vector of 3, 0, 1. When I augment there, I'm now going to once again row reduce, and so here I go do that. This is my row reduction for the last eigenvector. I'm going to go ahead and set up the equations I see here. This says x1 plus x2 equals -4. The second row reads x3 equals -1. Once again, I can choose whatever I want for x1 or x2 so long as it equals -4. So I'm going to say x1 is -4 while letting x2 be 0, and x3 by default must be -1. Okay, I now have all 3 eigenvectors. So now it's time to generate my solution. We start by putting the 3 eigenvectors in a matrix side by side. So we have -1, 1, 0, followed by 3, 0, 1, followed by -4, 0, -1. Then I create the matrix exponential. Matrix exponential just takes e to the -2t, puts it on the main diagonal, putting zeros underneath the main diagonal. And because this was a repeated eigenvalue where I had to generate these next eigenvectors using a Jordan cycle, when I go up from e to the -2t, the element above will be t e to the -2t and t e to the -2t. And now when I go up again, because I have an empty value here, when I go up one more time, I get t squared over 2 e to the -2t. That's our matrix exponential. I then say times p inverse. I just need to have that on the right-hand side of my matrix exponential. And lastly, times the initial condition, the vector of 7, 2, 0. Once I've done that, this is my full solution.